Am I audible to you all? Please write in the chat box if not audible. Or if I'm audible, then please write also yes. Okay, okay. Yes. Did someone raise a hand over here? I cannot see. If you have any question regarding this, you can ask in the chat box. Okay. Otherwise, I will start in a bit. You all have to close your video and mic also. Okay. Everyone, please turn off your camera and your mic. Okay. So I will be starting. First, let me share my screen. I think enough people have joined over here. Okay. So, just a second. So welcome you all for this NPTEL tutorial session for the power system engineering. I myself, Mohammad Owais Khan, the Prime Minister Research Fellow at the Department of Electrical Engineering, Aligarh Muslim University, will be taking this course. So, what I'm going to do here is that you have already gone through the lectures of the power system for the week one. So, this tutorial session is regarding for the first week. So what I will do here, I will summarize whole week's learning here, and then we will solve some other questions. and I urge all of you to actively participate in the question answer whenever I try to solve here. So basically, what will for you is that it will allow to get a better understanding of the subject. So let's move on to the topic regarding the first week we have is so basically in the first week lecture what you have gone through here is the regarding the topic of overhead overhead line insul. Okay, तो इसमें क्या है, you must have gone through various aspect, what are the various component of an overhead line, what is their what are the various components of an overhead line. Okay, like there is a conductor, obviously, without that it is of no use. Then and to support that conductor, there are various supports. I think people has to, you know, mute their mic. Okay. Now after that, there are insulators which are attached to the supports and to insulate the conductor from the ground. Okay. Then there are cross arms. What they do here, they provide the support. They provide the support to the insulators. Then there are various plates like lightning arresters, and like danger plates, sign plates like this. They are the component of an overhead lines. So basically, before I start in detail about what are the component, how they are going to support over there. So why we need a transmission line? The basic question arises, why we need a transmission line? So basically, the requirement of the transmission line is that because a generation is happening at one place, but the demand for the generation is at the other place, which may or may not be far away from the generation location. So the reason why we generate far away from the load center, there are various reasons. First is because, like for example, if we have a thermal power plant, if we have thermal power plant, then what happens here is that for a thermal power plant, the availability of a coal is very much important. So it is not necessary that wherever the load centers are there, the coal will be available at those centers. So basically, the generation plant for thermal power plant like this will be made on those locations where the availability of the coal is high. Another is the thing is the transport. If not the availability is not good, but the transportation of the coal is easier to that place. So we select those places for the generation where the availability of the coal is high, or maybe we can easily transport coal. So that's why the generation of the electricity, for example, using thermal is done far away from the load center. The reason behind this is this, that those locations the coal availability will be high, or it is easier available, or another factors which lead to the generation to the far away places is the transportation of the fuel. Like for example, coal, if there is we are going for a hydro, so the water is easily available on those locations. Then we are going to manufacture develop or build a hydro-based power plant. So basically, that's why now if the generation is happening at those locations, then we have to transmit these energy or power over the transmission lines. So that's why the transmission lines is a very much important requirement of an electrical power system. Now coming to that, what are the various types we can transmit the power? Either by in air, or we can say overhead, above our head, overhead lines, or we can use it by underground. Underground. Okay. So by using underground. So now there is a slight disadvantage regarding the underground power, underground lines or cables, because if we have to transmit for a larger length, like for more than 500 kilometers or like 1000 kilometers, so what happens here is that then we have to dug the ground for a so much length, and it is not very easy to dig the ground, because there will be some places the residential areas will come like no, like that. Then there will be some places which are not stable for for digging this the ground. So basically it is a one of the way we can use the underground cables, but it is not an economical viable, because digging the ground will lead to a higher cost, and eventually that cost will be reflected in our energy rates. So therefore, what generally has been prescribed is overhead lines, and the overhead lines has is less costly than the underground cables, and issue of flexibility flexibility is also very less. Okay, like in underground the flexibility, we don't have so much flexibility. So that's why the overhead lines are more preferred choice of transmitting the power. It is more preferred choice to transmit power due to economic reasons, and also ease of installation, and less affected by the underground conditions. बट लेकिन इससे ये नहीं रहता कि overhead lines will not be affected by the weather condition. They are also subjected to the various uncertain weather condition. Like there will be like in a plain regions there will be high temperature in the summer season. They have to withstand that. They also have to withstand high speed winds, because in general the overhead lines are have a high weight. So so they have to withstand the high wind speed also. And they for example, if these line extended to the regions where the temperature is goes down to minus, then they have to bear the ice or snow conditions also. So like I have said that we switch from the underground cables to the overhead line for economic reasons, for like various reasons which I have discussed. But overhead lines are also not a very easy choice. There are various difficulties. Like they have a high temperature in a summer, they have to withstand the high speed, they have to bear the icy and the snow conditions. So these are all are the factors which affects the overhead line. For removing these factors, we will discuss what are the ways we can remove these factors. So now coming to the main thing, which is the main component of an overhead line. Main component of an overhead line. So first is the primary condition is the conductor should be there. Of course, without the conductor, the line will not be there. So basically, what will do? It will carry the electric power. Okay. Then to support that conductor, we have various supports like poles or keep a conductor at a suitable at a suitable length. So supports the conductor in hanging, okay, and keep the conductor from the ground, okay. Then another which is very important is the insulators. These are attached to the supports and helps in insulation of the conductors from the ground. Then in order to support these insulators, we have cross arms. Then after that we have lightning arresters. You must have heard about this, lightning arresters. Then we have various plates which shows the nomenclature like the danger plate, phase plate, what are the phases are connected to this. Okay, so uh, therefore, these are the main component of an overhead line. So now we will discuss like various conductors. What are the conductor materials we can use for this? I hope till now you have get a better idea regarding this why we are going to use an overhead lines, not the underground lines, because underground lines is a costly affair and it is very costly. और अगर ये कोई ऐसे कंजेस्टेड एरिया से मूव करेंगे तो प्रॉब्लम क्या होगी, कंजेस्टेड एरिया में हम जो ग्राउंड का क्लियर ज़्यादा जगह नहीं होती, तो दैट्स वाई we uses the overhead lines. और overhead lines में क्या है, there are various problems regarding overhead lines also. The reason is they have to bear the weather conditions. Okay, now coming to the conductor materials. Now the conductors which are used for the transmission should have a high electrical. This is very much important because there will be questions regarding, in your exams or in any interview, what type of conductor material should be used for the electric power transmission. So it should have a high electrical conductivity. Okay. Second, it should have a high electrical conductivity and high tensile strength. High tensile strength. High tensile strength, why it should be? So that it can withstand it can withstand the mechanical stresses. Okay, this is also one of the most important. Electrical conductivity should be high, but the tensile strength of that conductor also should be much greater. Next is the low cost. Low cost. The This is also one of the most important property of the conductor material. It should be of a low cost. Either if we use a material which is of higher cost, then we will not be able to, economically transmit the power to a larger, larger distances. Then fourth is the its weight per unit volume should be small, which is also which is also a specific gravity, which is also the specific gravity. Okay, now coming to the various types of the material. So generally, right now, what we use here in modern ways is ACSR. What it is? Aluminium conductor steel reinforce reinforce. Okay, so these are nowadays generally used for the conducting of the for the development of the conductors. Now, after this, what is the next component is the support. So support. So there are various structures which we are it is used to support the conductors. Therefore, they are known as line supports. Now, the properties of the line support should be like they should have a high mechanical strength. Then they should have a cheap in cost, which is very much important. Cheap in cost, and so that economical usage can be done. Okay, and they should have a higher lifespan, higher lifespan. Okay, अब इसमें जो लाइन सपोर्ट्स होते हैं there are various types of line supports like steel poles, RCC poles, or lattice steel towers. ठीक है? Now coming to the most important part, which is insulators. Insulators. Okay. So what are these? You know. So basically, insulators, what they do, they insulate, provides insulation, provides insulation. Okay, provide insulation from the conductors. Okay, and these insulators must be non-porous. Okay, and free from any impurities. Free from any impurities. I think I am connected. Okay. Free from any impurities. Okay. The most commonly used insulators in any overhead lines is porcelain. Is porcelain, but there are various type of glasses or steatite also used for this. Okay. Now coming towards the another feature is that they should have a high mechanical strength also because they have to bear the conductor. So they have a high mechanical strength also. Now, there are various types of insulators. First one is the pin type insulator. Okay. The first one is the pin type insulator. Now, what is the pin type insulator? It is just like in a shape of a pin, like this is. I you must have. Okay. So basically, this is an pin type insulator. Okay. Now, here it is a galvanized steel pin. Okay. इसे here it is the groove for the conductor जिसके अंदर conductor fit होगा ठीक so this is the section of a pin insulator. It is secured to cross arm the probe. At the upper part, there is a groove for the conductor, and these are generally because now the thing is that there are various type like pin type, there are suspension type, shackle type. So they are basically divided on the base rating of the voltage they are used. So basically, the pin type is generally used up to 33 kV. Beyond that, the pin type economic can be used, but it becomes bulky, and it all because the number of the number of the pins gets increased, so it's become quite bulky, mm, quite bulky. That's why, uh, that's why, yeah, yeah. Just a second. Okay, that's why it become quite bulky. Then it become uneconomical to use. Yes. If you have any question, I think pin the queue. Just a second. You can write in the chat box if you have any question regarding this, okay? I will answer you. I don't know how to. Yes. Just a second. Yes, if you have a question, you can ask. Otherwise, I will proceed. You can write in a chat box, okay? I think chat box is open for all instead of raising a question, raising a hand, okay? So it's become quite uneconomical. So that's why the suspension type, the suspension, that's why suspension type insulators are used beyond the 33 kilowatt. Okay, so therefore, for a higher voltage greater than 33 kV, the suspension type of the insulators is used. Now, depending upon the working voltage, the number of the disc will be determined. So I will write it down here. One thing in a suspension type, depending upon the working voltage, working voltage working voltage, the disk will be provided on the string. Okay. Now, what happens here is this, in a like these are, I will draw it here. Yes, yes, yes. I will provide the lecture of the PDF of this, whatever I am writing over here. Okay, I will provide it, and also you will get a recorded, what we I say, you link of this whole lecture. I think you must have been hearing from the NPTL. They will provide you that also. Okay. So these are the disk depending upon the voltage. But the thing is that, so what happens here is that these are all connected in a series. So what happens here is that whenever they are connected to a series, there will be a capacitance. Yes, yes, yes. I'm telling up to the 33 kilowatt. We use pin type. We can use pin type for beyond the 33 kV, but it becomes quite bulky. Okay, so it becomes quite bulky, but also same time it becomes uneconomical because the number of them, the disk will gets increased. So what happens here is that instead of using pin type, we go towards the suspension type, and depending on the working voltage, the disk are provided. Like if we are going for 66 kV, then there will be six disks which are connected in a series like 1, 2, 3, 4, 5, 6, like this. Okay. Now what happens here is that whenever we connect, this is the tower and this is the conductor. So what happens here is that whenever the discs are connected, the voltage profile, or I would say voltage distribution. Yes, yes, kV, 33 kV. Voltage distribution is not uniform. Okay, is not uniform. The reason behind is that because there will be a capacitance in between this disk. So basically, what will happen here is that I will, draw it like here. There will be a capacitance. Okay. So due to this capacitance, the the distribution will not be same. And another is that another is another first is this second reason, the non-uniform voltage distribution is also due to the shunt capacitance. Okay, like this between this, so what happens here is that the regarding over over this here is this. First I will write it down here. First thing is that non-uniform non-uniform voltage distribution. Non-uniform voltage distribution. Okay, और सबसे बड़ी बात another thing is the unit nearest to conductor. Yes, just like this is the conductor. तो इसके पास जो यूनिट होगा, it has maximum stress. Units nearest to the conductor has maximum stress. Maximum stress. Okay, like this. Okay. Now अब क्या होता है, इसमें एक टर्म होता है which is known as string efficiency. You must have heard about this. It is string efficiency. Okay, before that, I will discuss about another insulator, which is, strain, strain insulators. अब क्या होता है जनरली when we transmit the energy from one point like from A to B. Now, after B, it may or may not be the requirement that we have to, there is a curve or there is a turn, like we have to go towards C, not here. So, in order to turn the insulator, we use strain types of insulator. So, where are the strain type insulators are used? When there is a dead end, because beyond this there is no line. The line is have to move like this. When there is dead end of the line, or there is a sharp turn. Okay, this is a sharp turn. If like from A to B, now we have to stop it here. Then what we'll use? We will use strain type of insulator here. Here here what we'll be using here? Here we will be using strain insulator. So basically, when there is a dead end of a line, or there is a sharp or a curve or corner, line is subjected to have a high stress. ठीक है? So in order to support that, we use strain insulators. Strain insulators are used there. Okay. Okay. Sir, for long using there will be a drop. How this paint? I will answer your question in a bit. KSPB Verma. I will answer your question in a bit. Okay. The- Uh, as we progress in a lecture, your answer will automatically get you know solved. But I will answer it in a bit. Just let me finish it first. Okay. Okay. Strain insulators are used. तो इस टाइप के इंसुलेटर्स कहाँ यूज होते हैं? इस टाइप के insulators use होते हैं when there is any dead end or there is a sharp or a corner, then line is subjected to have a high stress. But अब क्या होता है इसमें? If these lines are of low voltage, like less than 11 kV, then these insulators, shackle insulators will be used. Beyond that, we will use स्ट्रेन इंसुलेटर्स. ठीक है, उनका नाम जब लेस देन 11 केवी पे हमको कौन कौन से यूज करते हैं? We will use shackle insulator. Yeah, if there is any dead end or there is a sharp corner which is of a line of a higher voltage, then we will use a strain insulator. Okay. So now, so basically, I have discussed a term which I am going to discuss here is string efficiency. String efficiency. Okay. अब क्या होता है? जैसे हम जो है कोई भी एक टॉवर है, उसमें हम कंडक्टर को सपोर्ट करने के लिए हम क्या लगाते हैं? दीज इंसुलेटर्स. ओके. जब ये इंसुलेटर्स होते हैं, तो जनरली इन एन आइडियल थिंग व्हाट इट विल बी, the voltage between this and this should be equally distributed in an ideal case. But the problem is that due to the presence of these disk, there is a formation of capacitance. There is a formation of capacitance, and these capacitance will lead to the unequal unequal voltage distribution across the disk जो हम इंसुलेटर में लगा रहे हैं, ठीक है। ओके, और इट इज, अब इससे क्या होता है, व्हाट इट विल डू हियर, द प्रॉब्लम विद अनइक्वल डिस्ट्रीब्यूशन हियर इज दैट कि जो डिस्क हमारी कंडक्टर के पास लगी होगी, इट विल हैव अ हायर स्ट्रेस देन टू द डिस्क विच इज कनेक्टेड नियर टू द टावर, which is away from the conductor. So basically, it will lead to the unequal distribution, and this unequal distribution is undesirable, and it is very much undesirable. Okay, इससे जो है मैकेनिकल स्ट्रेंथ ऑफ द डिस्क हमको अलग अलग उसके लेनी पड़ेगी, ठीक है। सो रिगार्डिंग योर क्वेश्चन, द लॉन्गर डिस्टेंसेस यूजिंग ओवरहेड देयर विल बी वोल्टेज ड्रॉप, ओके। However, this pin type insulation effect, so you get the idea कि हमें जो है जो पिन टाइप इंसुलेशन और जो भी सस्पेंशन टाइप इंसुलेटर्स यूज कर रहे हैं, उसमें वोल्टेज ड्रॉप कैसे हो रहा है। वोल्टेज ड्रॉप क्या हो रहा है कि यहाँ पे जो कंडक्टर को सपोर्ट करने के लिए जो जो इंसुलेटर लगाया गया है, दैट इंसुलेटर in an ideal thing should have a equal distribution of the voltage regarding their disk, okay, but it is not happening. The reason behind I told you about it, it is due to the formation of a capacitance. Then what will happen here, the disk which is nearer to the conductor will have a higher stress, and it will have a higher voltage, okay, regarding that. So that's unequal voltage distribution across the disk is very much undesirable, okay. And this unequal potential distribution is across the disk is known as the string efficiency, okay. The greater the अब क्या होता है, higher the string efficiency, more
Calculation for this.
higher the efficiency, higher the efficiency, higher the efficiency, more more uniform is the voltage distribution, is the voltage.
Give calculation.
I think you should mute yourself, whoever is quite disturbing over there, okay.
Good, I am Balaram. Looking.
Okay, so more uniform is the voltage distribution. So 100% efficiency means 100% string efficiency means that voltage across the each disk will be same, but it is for an ideal case. So I will write it down here. I think you have get an idea what I am talking about. 100% string efficiency means voltage across the disk are same, but it is for a ideal case. For practical case, it is always less than 100%. For practical case, it is always less than 100%. The reason I have already told you about this. Why? What is the reason? कि formation of the capacitance. तो इसको हम equalize कैसे करते हैं? So there are various, thing regarding this. So first of all, I will write down the formula of to calculate the string efficiency. What it is? Se is equal to, there is a formula regarding this. Voltage across the string divided by N into voltage across disk nearest to conductor. Okay. What is N? N is the number of the disk in any string. In any string. Like for example, there are here N is equal to 3. This is the conductor. This is N is equal to 2. Okay. So now, what are the various methods to increase the string efficiency? Okay. So by using, first of all, by grading the insulators, by grading the insulators, we can improve the string efficiency. Okay. How it will be used? What happen here is that ki we will choose insulators of different dimensions, different dimensions, so that they have different capacitance. Okay. So what will happen here? They are assembled. They are, I will write it down here so you get a better idea. They are assembled in the string in such a way that top unit has minimum capacitance, top unit has minimum capacitance, and their capacitance increases progressively from top to bottom. इससे क्या होगा? Voltage is, what will happen here? Voltage is, I think you all know that, inversely proportional to capacitance, to capacitance. So what will happen? If C increases, voltage will get decreased. So the voltage will equalize. Okay, this is how, this is how string efficiency can be increased. Another method to increase the efficiency is by using guard ring. By using guard ring. So what happens here is that, so basically the potential, the potential across each unit is equalized. What is our aim? We have our aim is to equalize the voltage across the disk by using a guard ring. And what it is this guard ring? This ring is a mechanical, sorry, just a second. This ring is a metal ring, electrically, electrically connected, electrically connected to the conductor and the surrounding bottom insulator. ठीक है, जो लास्ट वाला जो कंडक्टर होता है इससे कनेक्ट कर दिया जाता है और इस तरीके से, ठीक है, तो ये गार्ड रिंग होती है। ओके, so I think we will solve some questions on this. It will give you a very much good idea how this equalization or string efficiency will be calculated. We will solve some questions today itself. So basically, this is all the thing. Now we will move on towards, I think, towards the questions 10, 11, 12 from the week one. Okay, just let me see it first of all. Questions. Okay, 10, 11, 12. Actually, I will explain all the questions, but I will see it first. What are you trying to say? Okay, it's not a problem. I will solve all these questions regarding this. Just a second. Okay, 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 okay. Just so we will solve some questions. So basically, so what will I will do? I will write these questions over here. Then you have to give me the correct answer in the chat box. Okay. So let's move on towards the first question. The most commonly used insulator for overhead line is first porcelain, B glass, C stearite, D none of these. So write in the chat box the correct answer to this. I will see who are answering. Okay, okay, okay. Let others answer also. I think we have only 10 questions in a week one assignment, which I have got the PDF. I don't know where you are saying 11, 12, because the PDF which I have. Okay, everyone is okay, nice. All of you are correct. So now question number two. The string efficiency of string efficiency is dependent on first type of insulator, B, size of tower, C, number of disk, D, none of these. Okay. Number of the disk. Yes, yes, it is the okay. So for the first question, the correct answer is porcelain, and this is the number of the disk. Okay. Now next question here is question number three. So uh, in a string of suspension insulator, in a string of suspension insulators, the shunt capacitance can be decreased by first longer cross arms, B, shorter cross arms, C, longer span, D, none of the above. So tell me the correct answer. So people are saying yes, longer cross arm. Who are saying no? Longer cross arm is the correct answer. Okay. So now another question, the question number four. You should calculate this. The voltage across the disk are 5.52 kilovolt, 6.13 kilovolt, and 7.4 kilovolt. ठीक? For a string of three, for just a second, for three units in the string. Okay. The OHL, overhead line voltage, is 33 kV. Okay. So now you have to tell me first. पहला बताओ voltage across string is? Okay, इसका आप कैलकुलेशन करके मुझे बताओ क्या है. You have to write the answer in the chat box. How did you calculate that? Voltage across string. Yes, 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 yes. Let other answer also. Yeah, 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 get it. Let other people also, try. What is right or wrong, I will tell after that. If some of three, four people also answer that, then after. Anyone other? Then Raja Gopal and Lucky Agarwal. 19.08. Okay. Yes. So the voltage across the string is just the same. It is the voltage across the phase, which is phase voltage, which is 33 by root 3. If we calculate, it will come out to be 19.054. Okay. Now people have, okay. Now the string efficiency, you have to give. String efficiency calculate karo. 54.6. Okay, let me calculate it first. Anyone other than 85.81? Okay. Yes, yes. So how do you calculate that? It's a very simple formula. Voltage across the string. Voltage across string. No, 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 no. Like it's 54.6 is not a correct answer. Okay, I will solve it for you. Just see here. So what is this string efficiency? Voltage across the string, then number of the disk into voltage across last. Okay, I have just told you about this formula. Let me show it for you. Okay, yeah. Voltage across the string divided by N, voltage across the disk nearest to the conductor. So it is giving in a such a way that this is of first, this is of second, the nearest to the is third, which is 7.4. So basically, string efficiency will be 19.05. We just calculated. Number of the disk here is 3. Then voltage across the nearest conductor to the insulator nearest to the conductor, it is 7.4 because it has been given in such a way. If we calculate it, I think it will come out to be 85.8 percentage. Okay, I hope you have understood this. Yeah, whatever it is, 85.08, you just calculate it. Okay, I'm just giving you an approx answer. So basically, it will be 85.8%. Yes, 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 85.89, something like that, depending upon the. Okay, so I think you have got an idea how we are going to calculate, you know, uh, the capacity string efficiency. So now moving on to our another question. Just a second. Actually, people should mute yourselves because there is some disturbances coming. Okay. Now what I'm going to solve you here is the okay. Now another question. The question number I think which is 4, 5. The question number 5. In a string of suspension insulator, in a string of a suspension insulator, the voltage distribution, the voltage distribution across the units, different units, across the different unit of a string could be made uniform by the use of by the use of grading ring because it first just a second, it forms capacitance with link pins to carry the charging current, okay, from link pins, ठीक, forms the capacitance which help to cancel charging current from link pins. C increases the capacitance of lower insulator. D decreases the capacitance of upper insulator. So give me the correct answer. A, B, C, D. Write in the chat box. B. Anyone else? यस यस। तो क्या होता है, जनरली जो यूज करा जाता है ग्रेडिंग पिन, इसको यूज करा जाता है टू रिड्यूस द कैंसिल द चार्जिंग करंट। चार्जिंग करंट इंक्रीज हो जाएगा, देन इट द वोल्टेज डिफरेंस विल नेवर बी इक्वल. So first option says form the capacitance with the links to carry the charging. No, it cannot be like this. Uh, Other than increases the capacitance of lower insulator. No, because the capacitance lower in का increase करते हैं, but that is done by different techniques, not by this. Decrease we cannot. So basically, main thing is form the capacitance will help to cancel the charging current. Okay. So now next question here is, so what happens here is that we have now talked about various things, like how do we, the regarding the sting efficiency or like that all. There is also another term which is you have gone through in the lecture, which is seg. ठीक है? Seg क्या होता है? What is seg? Basically, in an ideal condition, what should be, like for example, there is A, there is B. A line should connect like this. But the problem is that line has a weight. Okay? It has weight. So what happens here is that instead of in a straighter fashion, under the effect of his own weight, it bends like this. It bends like this. Okay? So basically, what happens here is that the amount of the bending from this is known as the sag. And why it is the happen? The reason is first due to the weight, it will bend under the effect of the gravity. So you must have gone through. I'm not going to calculate how we are going to calculate the formula for the seg. I must, you have, gone through there. So actually, there are two types of the seg. Like and B are on an equal level. For example, A is like A is here and B is here. So if a a transmission line is connected, in an ideal case it should be like this, but it is not happening. So what will happen here is that it will go like this. Okay. So basically, in this, just a second. So this is above H. Okay. Now what happens here is that, and this is let's say this is the O point. This is O point. Here O point is this. Okay. So basically, this much is the sag is here. We already know this. If we calculate this, we can calculate this much. So so sag are calculated for two. Here, equal level, support, और ये क्या होती है? Unequal level support. I think you must have gone through the regarding that, because the time is not here to calculate all those things. For equal level, the sag is wx square by 2t. Okay, what is x? there is this is okay. L by 2. This is L by 2. L is the span length. L is the span length. W is the weight of the conductor per unit length. T is the tension in the conductor. Okay. So X क्या करेगा? X को हम यहाँ पे क्या रखेंगे? क्योंकि इस पॉइंट पर सैग है और जनरली for a equal support length, the sag is always equal x is equal to L by 2. So if we put that x is here L by 2, so what we get here for equal level support, जो sag की जो कंडीशन होती है x जो होता है जहां पे sag हो रहा है x is the place at which is the lowest point. I will write it on here, lowest point. Okay, this is the lowest point in a overhead line. When this live session material link is available, actually I will share to the NPTL right now after the lecture, and maybe they will share it. They must have shared you, like a Google sheet to you. Yes or no? They must have shared a Google sheet to you. So basically, after that, I will share that link on the Google sheet, and you can get from there the lecture or all those things. So for a equal level, x क्या है? X is the point in the overhead line. So if we put that x is equal to L by 2, it will equal to WL square by 8T. So this is the formula to calculate the sag. Okay. So I will, share, I will solve a question on this sag. Then we will move on another question. So calculate, I have a question, let's say, just a second. Okay. If the span is increased, then sag. What will happen to the sag? First, decrease, B, increase, C, none, D, remain same. Okay. You should answer that in a chat box. Last slide. Okay, okay, just a second. This is question number, I think, 6. Okay, yes, x is directly proportional to span length, so it will increase. Okay, so now I think, yes, okay. Now, next question, question number 7. If the safety factor, if the safety factor and the puncture voltage, puncture voltage of an insulator are 1.6 and 72 kV RMS respectively, What will be the flash over voltage? A 60, B 45, C 28, D 73, D 72. So give me the correct answer. Okay, if the safety factor and the puncture voltage of an insulator are 1.6 and a 72 kV RMS respectively, what will be the flashover voltage? 45. Okay, let, let me see what is the correct answer. 45. Okay, so what is, so we will solve it here. Factor of safety. Factor of safety is equal to puncture voltage divided by the flash over voltage. Okay. So what is the puncture voltage here? What is 115.2 kV? It is 72 divided by 1.6. Sorry, just a second. Okay. So factor of safety. What is the factor of safety here? It is 1.6. We have to calculate the flash over voltage. What is the puncture voltage which is given? 72 kV RMS. So if we rearrange, the flash over voltage will be equal to 72 kV RMS divided by 1.6. So it will come out to be 16, 40, 45, yes, 45 kV RMS. Okay, this is the main thing. So the correct answer of this question will be 45. Okay, this is in kV RMS. Okay, okay. Question number 7, 8. Okay, a 3 unit insulator is fitted with guard ring. Is fitted with a guard ring. Okay, the capacitance of link pins to metal and guard ring can be assumed as 20% and 8% of capacitance of each unit. Okay, determine efficiency. So what will I do here? I will calculate this, okay, instead of letting you all solve. So I will solve it here. अब इसमें क्या दिया हुआ है कि 3 in unit insulator है. It is fitted with a guard ring and the capacitance of the link pins, let's say, of each unit. Let the capacitance of each unit is C. 1 is equal to C. Then capacitance of link pin, let's say it is C2, which is equal to, I think, 20%. So it will be 0.2 C. Okay. Then the guard ring, let's say this is C3, which is equal to 0.08 C. So finally, what will be here is this. This is the, okay, this is C1. Just a second. Okay, this is the support like this. So C2, which is the link pin, it is connected here, and these are all link pins. Okay, now what is C1? C1 is the capacitance of each unit, which is this. This is C1. Okay, this is the conductor which is insulated, and the guard ring are C3. So let me draw it with a different color. So guard ring will be C3, C3, and they are all connected like this. We have already told you about. So this is C3, this is C3, this is C1, this is C1, this is C1, and these are C2, C2, and C2. Now the voltage difference. So let's assume the voltage difference between them are like here it is V1, here it is V2. Let's assume the voltage difference here is V3. I'm not writing on the left side. Okay. If you have any confusion, you can go back to the video again. Okay. So it will save our time. So this is the point. Let's say this point is P and this point is Q. Okay. And this is the conductor. So first of all, what we will do here, we will apply Kirchhoff's current law at P node. Okay, इस पॉइंट पे लगाएंगे. बात समझ में आ गई? So what we will do here at P node. Okay, so it will be like this. How we calculate I? I is equal to omega CV. Okay, this is the way we calculate the omega. So depending upon the, ठीक है. So just a second. If we apply the Kirchhoff's current law at P, so omega C1 V2, omega C1 for this across the voltage is V2. ठीक है? For this across C1 it is the voltage C2 V2. plus C3. Now for C3, the voltage will be V2 plus V3. Okay, these two voltage. So omega current from here, omega C3. Now V2 plus V3, because across the C3, across the C3, the voltage difference from here to here, it is V2 plus V3. Now is equal to omega C1, for across this is omega C1 V1 plus, now the current will go from here to this. Okay, so for this C2 is omega C2, and across this C2 the voltage difference is V1. So I hope you have understood how to apply the KVL at point P. Now if we rearrange this, now putting the values of C1, C2 and C3, so it will be C1 is C, so omega CV2 plus C3 is 0.008 C, so it will be omega 0.08 C, and V3 plus V2 is equal to omega C1 is C, V1 plus omega C2 is zero point 0.2 C2 V2. Okay, so it will be like this. Now after this, the common term, you can see here the omega and C are the common terms we just calculate, so that our, okay, just a second, it is C, because we have changed all this thing into C. So what will be remaining here? V2, V2 plus 0.003 plus 0.08 V3 plus V2, it will be equal to V1 plus zero point 0.2 V1. And if we arrange this, you can clearly see it is very simply like this. Okay. So if we solve it, rearrange this for V2. Let's rearrange it for V2. So it will be equal to V2 is equal to how much it will be? 1.2 V1 minus 0.08 V3, which will be divided by 1.08, and it will be divided by 1.08. You can do the calculation and it will come out to be 1.11 V1 minus point just a second, minus zero point zero 0.07 V3. So this is the, let's say this is equation 1. Okay, I hope you have understood till now. So I will recap it. First, what we will do, we have drawn the figure based upon the information given in the question. After that, we apply KCL. So conductor is here. The current will be going up like this here. So incoming current is equal to the outgoing current. Okay. So for C3, there should be a special instruction regarding this, that the voltage difference across the C3 is V1 plus V2. V1 plus V2. Okay. Now again, now we will again apply KVL at where? Q point. Okay, at this point. Same here. If we apply the KVL here, let me, okay. Uh, so incoming current, what it will be? Omega C1 V3. Okay, actually this is C1. Okay, these are all C1. So omega C1 V3. So we will write omega C1 V3. Then for this C3, what it will be? Omega C3, but here the voltage is just across this C3 is V3 only. There is no ring beyond this. So basically we will write here omega C3 V3. It is equal to how much? It will be equal to omega omega C1 V2. For C1, the voltage difference here is V2. So we will write it here omega C1 V2 plus omega C2. Now come to this C2. So for this C2, the voltage difference here is will be how much? It will be V1 plus V2 because the current will go here. So basically, this all voltage will get adds up. So V1 plus V2. Now applying the value same. So what is C1? C1 is C, V3 plus C3 is point zero 0.08 CV3. It is equal to omega C1, which is C V2 plus omega C2 is zero point 0.2 C V1 plus V2. No, no, no. Actually, that is C1. C1, C1, C1. It's not C2. It's mistakenly I have wrote over there. Okay. I think I have just corrected here. This is C1. Okay. So same omega C cancels out. Same thing. And then V3 plus zero point zero 0.08 V3. I think I have done correctly till now. Maybe if there is some calculation error, you can check it here. Okay. Yes. Okay. So it will be 1.08 V3. It will be equal to 1.2 V2 plus zero point 0.2 V1. I think it is correct up till now. You can give me a confirmation in a chat box. Okay. Great. Then again, we will solve it for the V3. Solve for V3. So if we solve it for V3, I think it's quite clearly 1.2. Okay. Zero point 0.2 V1 divided by 1.08 plus 1.2 V2 divided by 1.08. I think it is correct. Okay, yes. So if we solve it, then V3 will come out to be how much? It is 0.185 V1 plus 1.11 V2. So what happens here is that this is the equation 2. See, I have done a trick over here, and you should always do that, like, because in the end we have to calculate the string efficiency. So string efficiency will be equal to sum of all the voltages divided by the lowest voltage. Okay, so basically I will write the first equation V2 over here. V2 is equal to V2 is equal to 1.11 V1 minus 0.74. Okay. Actually it will be 0.074. Okay, V2. This is the first equation. Oh, just a second. Okay, this is V3. This is V3. Okay. So what will we do? We will, I think it is correct. 1.11 V1 minus 0.0734. Okay. Yes. We will put the value of V3 over here. So it will be V2 is equal to 1.11 V1 minus 0.074. What is V3? 0.185 V1 plus 1.11 V2. Okay. So if we solve it, I think you can use a calculator. Solve it for V2. So V2 will comes out to be 1.0974 V1 minus 0.0823 V2, and rearrange to get V2. V2 will come out to be around 1.0139 V1. I think it will be the answer to that. So what we get? We get V2 is equal to this. V2 is equal to 1.0139 V1. Okay. And if we replace V2 here, we will get V3. Replace V2 by, let's say this is equation third, by equation third in equation second, we get V3, which will becomes out to be 1.3118 V1. Okay. So keep this thing in mind. Always we there are three variables, and we have already we got only two equation. So we cannot solve this equation, but we can calculate the string efficiency. You can see the trick. So this is the V3. This is V2. Okay. Let's say this is 4. String efficiency क्या होती है? What is string efficiency? Sum of all the voltages V1, V2, V3, and number of the disk multiplied by the voltage across the last bottom, which is V3. You can see it over here, V3. Okay. So what is V1? V1, we have calculated the value in terms of V1. So V1 is V1 plus V2, 1.0139 V1 plus 1.3118 V1 divided by N. N is 3. What is V3? 1.3118 V1. Okay. So eta, which is the string efficiency, now give me the value of V1 by adding all those. Right in the chat box. And also multiply 3 into 1.3118 V1. Give me that value. First of all, give me the value of above. Okay, I get it. Okay, you already calculated string efficiency. Great. So let me write it. So V1 is calculated, and as per you, other people, I think it will come out 84.51. 84.51%. Okay. So the string efficiency is 84.51 percentage. Actually, options are there in the is like 76 to 78. B option is 80 to 82. C option is 84 to 86. These are all in percentage. Then D option is 87 to 89 percentage. So based on that, we can say here C is the correct answer. Okay. Options are giving in terms of the ranges. Okay. Now next question, question number 8. What is the question number? Ninth. Question number 9. Actually, in this question, I think you all have the answers to this. Once show the diagrams. Actually, we have less time. You can go through the diagram once I share the because I have to complete two questions or more which are very much in detail. Okay. So basically, in the question number 4, they have consider a 50 hertz three-phase system. I hope you understand that. Three phase 60 kilovolt distribution system. Okay, it is like this. Okay, the diagram I will draw it here. You can go through the question in your assignments. I will solve it here. The question is given like this. This is the conductor. Okay, so it is given, consider a three-phase 50 hertz 60 kilovolt distribution system. Each of the conductor is suspended by insulator string having the two identical porcelain insulators, and the self-capacitance of insulator is 4.5 times the capacitance between the link. So basically, it is saying, let's say this is C, so it will be 4.5 times C. Okay, as shown in the figure. The voltage across the two insulators are, we have to calculate. So basically, let's say the voltage across this insulator is E1 and the voltage across this insulator is E2. So E1 and E2, we have to calculate. So first, let's say this is point M, apply KCL at M. So incoming current, what it will be? 4.5 omega C E2 for this. It is equal to omega C E1 plus 4.5 omega C E1. I think it is quite explanatory. I don't have to go in details. Okay. So basically, what we will do, we will remove the common things. So what will it come? 4.5 E2 is equal to E1 plus 4.5 E1. Okay, 4.5 E1, and E2 is equal to 5.5 divided by 4.5 E1. You give me the answer. Divide this and give me the value in the chat box. What it will be? 5.5 divided by 4.5. I think it will come out to be like yes, 1.22. Yes, 1.22 E1. So E2 will be equal to 1.22 E1. This is equation 1. But the problem is we have to find the value of E1 and E2. But there is only one equation and there is no other equation given because we cannot apply another KCL at any point because the common point is this. So basically, the in the question it is given, it is of 16 kilovolt. So basically, E1 plus E2 will be equal to the 16 divided by root 3. So it will be equal to 9.2376. Okay, this will become the second equation. So if we solve it for E1, so E2 is 1.22 E1, which will be equal to 9.2376. And what it will become, I think this will be 2.22. Give me the answer by dividing this in the chat box. So E1 will be equal to 9.2376 divided by 2.22. What is the answer? E1. Yes. Okay. Let me check it. 4.16. 5.07. I think it is 5.08. Anyone else other than no one? Okay. So this is the options. So basically the correct answer will be, you can see the correct answer will be D in your assignments. Okay. I hope you have understood how we can calculate, how we can, apply. Okay, once show the diagram. Okay, which diagram are you talking about? This one? Okay, now question number 10. A string insulator, a string insulator has four units. The voltage across the voltage across the bottom is 40% of total voltage. Calculate. Now you all have to calculate the string efficiency and give me the answer. Options is 56 to 57%, B 62 to 63%, C 68 to 69%, and D 74 to 75%. So I will give you a 5 minute time, then you should give me the answer. 75. Let me see it. B 62 to 63. Okay. Let me solve it for you. String efficiency क्या है? It is voltage across the strings. So here we have four units. So V1 plus V2 plus V3 plus V4. Okay. Let me see क्या आंसर आता है. Then I will say who is wrong or right. And divided by number of units, which is 4, multiplied by the voltage across the bottom unit, which is 4. It is quite obvious. So basically, what we are going to do here is, in it is said that 40% of the total voltage. So V4 किसके बराबर है? V4 will be, let's assume the total voltage is V. Then V4 किसके बराबर हो जाएगा? Is 0.4V. और टोटल वोल्टेज किसके बराबर होता है? V1 प्लस V2 प्लस V3 प्लस V4. So string efficiency will be V divided by 4 into 0.4V, and it will be comes out to be 0.16 If you multiply it by 100, it will come out to be 62.5%. So based on that, the correct answer will be B. Okay. Now, another question. Question number 10. Actually, don't mislead this number with your assignment question, okay? So, I hope you have understood regarding this. So, now the ratio of capacitance between pin and self capacitance is 0.125 C. ठीक है? For a string of 2 unit. ठीक? The maximum voltage across any unit should not exceed how much? 10.5 kV. Find the maximum phase voltage. Maximum phase voltage this insulator can withstand. A 11 to 12%, B 15 to 16%, C 19 to 20%, D 22 to 23%. तो आई विल सॉल्व इट फॉर यू. अब इसमें क्या है कि एक तरीके से ये बनाया गया है कुछ इस तरीके से. ये इसके पिन है, ये सेल्फ कैपेसिटेंस है, दिस इज एनोडर, दिस इज कंडक्टर. ओके. तो इसमें क्या दिया गया है, द रेशियो ऑफ द कैपेसिटेंस बिटवीन द पिन एंड द सेल्फ इज 0.125. तो इसका क्या मतलब वो होगा, जो पिन वाला है उसका कैपेसिटेंस 0.125 सी है, तो इसका कितना होगा सी. सेम फॉर हेयर. तो वोल्टेज बिटवीन देम इज, लेट्स से दिस इज E1, दिस इज E2. सेम प्रोसीजर. अप्लाई KCL at apply KCL at, let's say this is M, at M. So what will happen here is omega CE2 is equal to omega CE1 plus omega 0.125 CE1. So omega will cancel out from here. Then it will be E2 is equal to E1 plus 0.125 E1. It will come out to be 1.125 even. Now, so basically E2 is equal to 1.125 even. This is the only equation we get by solving this. But the problem here is that we have two variables and one equation. So there must be some information given in the question. In the question it been given the maximum voltage across any unit should not exceed 10.5 kilovolt. kV. Find the maximum phase voltage. And we know that कि maximum voltage कहाँ occur होता है? It is occur towards the maximum voltage always occur at the unit close to the conductor. So basically E2 is equal to how much? E2 is equal to 10.5 kV. So by putting this equation in this, E1 is equal to, okay, E1 is equal to E1 is equal to E2 divided by 1.125 kV. So what is E2? 10.5 divided by 1.125 kV. So if we solve it, E1 comes out to be 9.33, yes, 9.33 kV. And E2 we already calculated 10.5 kV. But in the question it has been asked, find the maximum phase voltage this insulator can withstand. Okay, वो कितना होगा? वो क्या होगा? मैक्सिमम फेज वोल्टेज कितना होता है? मैक्सिमम phase voltage will be equal to the E1 plus E2 because here is only two units are there. So it will be even 9.33 plus 10.5. Give me the correct answer to this by adding this. It will be around 19.833 kV. Okay. So we can go from here. So the correct answer will be C, 19 to 20% because it is coming out to be 19.833%. Okay. So the maximum phase voltage it can withstand. Okay, it is this. I hope you have got the idea how to solve these type of questions. It is all clear to you, all of us? Okay, okay. There are several questions also there. I think in the next lecture we will solve those questions. Okay, there are two, three questions have been there, but we have already reached our time. So I will continue those questions in your, next lecture on Sunday, next Sunday. Okay, it will be every week Sunday from 3 to 5. Okay, I hope you got the, everything regarding information for this. Okay, 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 okay. So we will finish it today. Thank you for all joining. We will meet again next. You can leave now. If you have any question, you can ask. Thank you. Thank you.